When we look at just for the instrumentation, when we had to monitor the solution in production, we were like, oh, thankfully, we keep Ruby because now, consider that we have implemented another language. Now implement instrumentation in production would be too much. So instrumentation sometimes, oh, it's working on Rails, that's amazing, but other languages, they are not lucky like us.
Our next guest is coming from so far away, so freaking far away. I think almost the farthest away. He's coming from Brazil, but I think Nicolas. Okay, sorry. He's coming from Brazil. His name is Celso, and he's very, very friendly. So give it up for Celso.
Bună ziua! I'm trying to improve my Romanian, not there yet. Okay, Celso, I'm Celso. This is the GitHub, I think it's the best way to describe myself. And I work for the ClickFunnels for the past like 5 years, and I'm like Luso-Brazilian, living in Brazil, and that's why our like Romanian and Portuguese a little bit same grandmother, and my most friendly Brazilian Romanian friend Adriano. How many of you Romanians have like a Brazilian name? Adriano has one. That's amazing. Told me about a few like words and phrases that we have in common. So, 1 kilo de carne, 1 litro de láctea. So, also trying to improve. And Ruby in the billions. What about this billions story scale? This thing, billions. I know that billions is kind of like catch word, and I changed a little bit for Ruby and the billions. How to become a billionaire with Ruby. It's kind of like just follow my channel, subscribe here for more information. No affiliate links, I promise. Okay, how to get a billionaire with Ruby. And okay, getting back to the Ruby thing, not much the billions, but yes, how we leverage Ruby to process quickly billions of database records. And quickly is relative. If my talk is not that good, it's gonna like last forever. If I can make a little bit more interesting, it's gonna be fast, so I try to go as fast as possible. And it's a use case, but what is the problem that we faced? The problem is when you hit enter, you write some code, you have some process, you hit enter, and okay, 0.5%, that's amazing. Let me just grab some coffee. And then when you get back, you're still at 0.5%. And then, okay, oh, coffee just heats up. I'm just keeping all my things, and you look, it's like 0.7%, not as exciting. And then you start like melting down after the coffee, and it's 0.9. Damn, I start like now feeling sleepy. And I'm just gonna sleep, keep this running all night long, and I see when I get back, when I wake up, then you wake up, it's 2.5%. And this is the kind of problem that is disappointing. And the process itself takes 7 days. And okay, easy to solve. Just use a fast language. Okay, we choose this language, talk is over. No, I'm just kidding. We are really like a Ruby company. Sometimes people tell you should be using the best tool for the work, but we truly believe that sometimes Ruby cannot be the best, but given how we work, all the things, it's the best for us. And yeah, Ruby is awesome. Sometimes we need to think a little bit outside of the box, Rails, and Ruby is friendly. So it's a real use case. The use case is real. The talk is based on real events, maybe. But okay, so what is this problem? Database was out of sync. And it started becoming a problem when your database has billions of records. And what was this process? We had to synchronize both databases. And not just the database, because it was taking, remember, days. Changes are constantly happening to the database, so we need to sync all these changes in real time too. And how we're going to do this? Ruby for the rescue. So this is, let's think about this, the headline, how we can process it quickly and smash the Elasticsearch cluster. The database that we were synchronizing the data to is the Elasticsearch one. It's running on a massive hardware, massive cluster. So it was a really massive Elasticsearch cluster. And during that 7 days, the peak was like, I don't know, 10% of usage of the cluster, and we were like really disappointed with this first iteration of the process. And why we are here? Because I want to share this real use case. It's so amazing, blah, blah, blah. Now, but in reality, it could be how we went from default to production. And yeah, sometimes you're in production and this is fine. What was this problem? It's all about search. And search is something that is common, most of the apps. And I don't know, anyone has implemented search on the Rails app here? Oh, that's interesting. I don't know which solution you implemented, but when you search Rails, the default solution is SearchKick. Someone used SearchKick? Okay, so you're gonna understand the problem, what we experienced. So to work SearchKick, it connects to Elasticsearch, so we need to keep both databases in sync. And sometimes it goes out of sync. And it goes worse depending on the size of your data. But, okay, it's out of sync. We have a few solutions. Let's go to SearchKick README. Information will be there. We just copy and paste a few comments. If not, we go to Stack Overflow, copy and paste a few comments, and we're going to be fine. What is the first one? Model.reindex. That's how you always reindex it. That's how we started the POC on our local environment. It always worked. Not anymore. It worked the first time. We deployed model.reindex. Amazing. It worked. After a few weeks, we had to reindex again. Oh, we have like a parallel synchronization. It's going to create the background jobs. We're going to process. Yeah, that's amazing. That worked a few weeks later. But then we got 100 million of records, 200 million of records, and then this parallel was getting slower and slower. And this time, that took like 7 days, this first iteration, it started adding a lot of pressure on the Redis/Sidekick. We didn't have much control when to pause. We have about zero control about throttling. Throttling was not a problem. Elasticsearch cluster was at 10%, so throttling was not a problem. It was basically a fire and forget process. And what do we need? We need to think. I was watching pool with my daughter, and it was like, oh, you're going to add the pool on your talk? I was like, yes. So I had to keep my promise. The whiteboard. We went to the whiteboard, and what we had in our whiteboard. Ruby, MySQL, Redis, Elasticsearch, and Kafka. We're going to focus a little bit more on Kafka here. So who is used to Kafka? Okay, so I hope that you're going to get a glimpse about Kafka and understand how it works. So this is the diagram of the solution. We'll get back to this. But first, I want to talk about Kafka. Kafka was the bare bone of this solution. And here's the Kafka Crash Course 101. Focused on reindexing, Elasticsearch records, focused on everyday Ruby developers. So how it works? We have a stream of messages focusing on the terminology of Kafka. We have consumer A and B. They are independent, and they just go processing this stream of messages. But okay, but what is a message? Message is a JSON payload. Just take care about the encoding that you're going to use here. But it's the JSON payload. You'll be sending payloads through many systems. Pay attention to this. And yeah, let's think about consumer A and B for our case here. We can think a little bit that is like Sidekick, but it's sequential. So we can guarantee the order that we're processing the message, and we don't have that back-off retry. So if you don't process a message, it's going to pause. It's not going to advance to the next one. Let's see in action, a few slides ahead. And we have this anatomy of a topic. So this is stream of messages. You can think about lanes. You have different lanes. That is what we call topics. OK, Kafka Crash Course 102. Why we used Kafka for this scaling problem? It is designed for writes. So we could read everything that we had on our Aurora MySQL database. I'll just call database for now, or main database. And we could read once and write everything to Kafka. That's amazing because we pay for I/O on AWS, we pay for I/O, and we pay for I/O. So every time that we are reading a record, we are paying, and it was costing more and more money. Every iteration, it was costing us a lot of money. So writing to Kafka, it was not free, but way cheaper. And interaction. We have interaction. We have this, what is called choreography between different actors in the process. So let's think we have this message A. It is sent to all consumers, first, second, 30. They're on the offset 0, type of message A. The second one, I want to process message A and B. The 31, I just wanted the B. So it processed the message. They move to the offset 1. New message, message B here. So this is the stream of messages. And goes to everyone. Now the second one, oh, message B. I want this one. And they move to the next offset. And then another message B, go to both, and they're processing this stream of messages. I want to introduce these concepts of Kafka real quick because it's going to help understand how we scale. And talking about scale up and down easily. Remember these partitions that we have on Kafka? How it helped? It helped because you can have many stream of messages, and each consumer will be processing all these messages. So you can scale up and down how many consumers you want. And this was really good because at night, we want to go full speed, just index as much as possible. But on the peak hours, we need to cool down to not cause any kind of instability on our system. And possibility of replay messages in case of errors. This is great because we didn't have to reread all the messages from MySQL again. So saved a lot of money. How does replay of message work? All the consumers, they're here on the offset 3. You set just for 1 to the offset 0. It goes back. And then it starts replaying all the messages again, but just that consumer. That's an amazing feature. And we have persistent/ephemeral storage as needed. Depending on your topic, your partition, you can set some retention period like, I just want to store the last 1 terabyte. I just want the last 30 days of data. So it helps making your storage cheaper. And race car and deliver boy. We were already using these 2 gems on our production application, and we used this, and it's really amazing. I'll get back to this, but I could speak this 10 times. It's incredible how battle-tested and stable the Ruby gems are in our ecosystem. Sometimes we take this for granted, but when you look, oh, let me see how the other languages are playing with Kafka. Except Java maybe. All the other languages, they don't have all the stability that we have in Ruby. By the way, they use native extensions to bridge with the C Kafka library. So it's amazing to see it working. Now, Elasticsearch cluster 101. This one is way simpler than Kafka. And where is Elasticsearch on our diagram? They're like both here. They're like the end point of our data flow. And Elasticsearch, what is Elasticsearch? It's provided distributed, multi-tenant, cabal, full-text search with an HTTP web interface and schema-free JSON documents. We can think like a REST API for us. You can think, yes. And schema-free JSON, you can send any document. It's called, on the Elasticsearch terminology, it's called a document. So again, it's a JSON. And it's an append-only database. When you make an update internally, it's delete and write a new one. So there is no update on Elasticsearch. And the HTTP interface, that's what matters to us. Some example, just if someone is interested. I was thinking, I don't have music, video games to show, so let me put some JSON payload. I hope it's interesting the same way. Yeah, and the process flow. Now that we are getting used, we had all these concepts about Kafka and Elasticsearch. Let's see how we designed this. The search kick parallel, super simple to understand. You trigger the process, it queues thousands of sidekick jobs and sidekick process sending the HTTP request to Elasticsearch. Super simple. In this case, not as simple, but that's how we ended up. So we start the process. We publish our first message to Kafka. Let's kickstart the process. Woohoo! Cross our fingers. It's gonna work now. And we read the Rails active record information from the database and publish to Kafka again. This is the step that we end up saving a lot of money. And this boundary here is about the consumers that were running inside the Rails app. This boundary here is they're just Ruby Kafka consumers. Why this? We don't have to load the Rails application in memory. We could scale up and down super quick. Memory footprint was insanely low. So that's why we ended up splitting these two things. And I forgot to mention, this is the batch processing. We will see both, but this is the batch processing. And the next step, we built the Elasticsearch payload, so we had a consumer just for this task. And it was sending next, publish a new message to Kafka. Remember that message, those messages A, B, C? So this is what was happening. The first one, we can think about the first consumer getting a package, processing, send it to the next one, processing, the next one. So that was what was happening. And this two was sending to two different Elasticsearch clusters. That's cool, because SearchKick could just send to one Elasticsearch cluster at a time. But publishing the message to Kafka, we can add how many consumers we want. We just need to publish one message. Each consumer group read that message and publish to the cluster that they want at their own pace, how they want. We could split our unique atomic for 7 days, yes, but atomic 7 days process in little tiny process. And the real-time changes, remember, during hours, sometimes days, we had a lot of modification on the database. So we had kind of like active record callback that was publishing all the message to Kafka. We had a different Why not the same? Because this one, it was reading batches of records. Let's think kind of like the find each in Active Record. And this one, it was read just single record masters. But the payload they were building, it was getting kind of like a funnel here. So we're using a funnel that we just had these consumers send it to Elasticsearch. So if we had to stop sending the cluster, oh, you're causing any instability in the system, it's a turnkey. Just get these two down here, and everything is paused. And the message ended up on Elasticsearch. And this solution, a little bit more complex, but added a few things to the table. Let's just recap. Saved money, reprocessing masters. We could send it to different clusters. We have a lot of control here. The challenges. What are the challenges that we faced, and how was our experience with this? The first one, testing. Testing is in the Ruby culture, and it's amazing. I love it. You can think about all this diagram here, how many iterations it was happening all the time, being able to write code because, yep, tests are code, but writing tests that we could just run and make sure that we are sending all the message, the flow, guarantee all this process. It was really amazing. And what makes it really awesome in the Ruby land, for example, how we are going to test this interaction with Kafka? Let's jump in the race car and deliver boy gems. It's like Ruby code. It's all there. Just open the test folder, see how it's tested. Copy, paste. Yeah, sometimes that's the best way to test. Flattening database records. Yeah, a few things we take for granted. I don't know how is your relationship with RMs, but I love Active Record. I know SQL. Yes, I want to write SQL every single day for everything. Absolutely not. So the flattening of records, it was happening here because, remember, we can just store one JSON on Elasticsearch. So all the relationships must be flattened in one JSON. So we can think about what we get from Active Record. We can avoid N+1, the eager loading, all the GSL together relationship, the joins. Oh, it saves a lot of time. Writing this in a different language just to read from the database in the first step of the solution, no way. And Ruby Kafka ecosystem. Again, I could say 10 more times. How is this, the race car and the liver boy gems, is like in the bare bone of our solution here. So having all the stability using in production, native extensions. If I had to implement this, just to check if I could get from 7 days to 1 day, if implementing all this integration, if it takes me like 2 weeks, I would be net negative. So sometimes it's really good to just get something, use, and oh, it works really well. Instrumentation. I don't know how many of you have had to monitor infrastructure. And when you have some distributed tracing, you have all these messages flowing, you have different processes, each consumer group is a process itself, you have all these lines here. We can think about network, delays, timeouts, Ruby exceptions. It's a lot. And instrumentation, we have active support instrumentation. We have support on those both gems because it's on our ecosystem. Integration with New Relic, Datadog, which one you prefer. It's when you look at just for the instrumentation, when we had to monitor the solution in production, we were like, oh, thankfully, we keep Ruby because now, consider that we have implemented another language. Now implement instrumentation in production would be too much. So instrumentation sometimes, oh, it's working on Rails, that's amazing, but yeah, other languages, they are not like us. And for example, what I mean by instrumentation, remember those partitions, we have the offsets. So this consumer, it's on the latest masters. So okay, nothing happening, we are good. This one, it's here, the latest, almost the one, so technically speaking, it's what we call consumer lag. Nothing to worry here. But when we see a consumer group like this, that is on the latest masters, and here on the partition B, it is just on the second one, it's something that we need to go and understand what's happening. So this is the kind of instrumentation that I'm talking about in production. And interaction with 4 different services: MySQL, Kafka, Redis, Elasticsearch. Super easy. Gem, MySQL, Gem, race car delivery boy, Gem, Redis, Gem, Elasticsearch. It's working. We need to do anything. Consider any different language. How would it be just understand these protocols, implement all these things? So we saved a lot of time and effort on these integrations. And these integrations with these services, they were happening at this. In Redis, oh, why Redis? Why Redis is here between these two? It is how we implemented throttling. So every time we wanted to slow up or down, we were changing Redis keys, and we could create some kind of throttling. If you have any questions about the timeouts, makes no sense to go deep here, but we had to keep in 1 second all the requests, blah, blah. So if someone wants to talk about, just ping me. Lessons learned. Ruby is an incredible tool, saved us a lot of pain, a lot of time, a lot of money. And remember, in the beginning, we had this 7 days in Elasticsearch cluster. Yeah, we smashed the Elasticsearch cluster. And we ended up the process in 20 hours. So yeah, real scale here, 7 days to 20 hours. And it was super cool. Ruby, in the end of the process, how I felt about, I like playing with different programming languages. I'm a huge fan of Crystal. When I want to test a few things, usually I don't use Ruby for personal thing. I try different languages. But daily work, production thing, client-related thing, I want stability. I want stress-free solutions. I want to speed up things. So Ruby helped us in all these areas. Thankfully, we are a Ruby shop organization. Now some special friendly thanks to our Friendly.rb team. Thanks for having me here. Such a pleasure coming from that long. Thank you very much. ClickFunnels friends, they helped with the solution. This is not my solution. It's a team solution. I'm just the lucky one to be having this conversation with you. Few friends here too. My daughter for the pool inspiration. And you, thank you very much for being here, watching the talk, and make it all happen. I wish billions of good things in your life. I don't know if it's going to be money, whatever is good for you, but wish you these billion things. And mulțumesc!